Hello students, welcome to Gyanvyar School of Education, Suresh Gyanvyar University. I'm Dr. Sonia Kaur Bansal and today's my topic is related to chi-square test and subject is methodology of educational research. So students, let's understand about chi-square test, and today's learning objective of my class are related to the understanding of chi-square test in educational research, and I hope you will understand it attentively, listen it very carefully, and then apply the chi-square test in your research process. So let's start the chi-square test, what it is and how it is administered, what are its limitations, and how the chi-square test is very important in a research process. So to start with the introduction part, a chi-square test, also written as x square, what we actually see it in the way, but it is called as chi-square test. So it is a statistical hypothesis test that is valid to perform when the test statistics is chi-square distributed under the null hypothesis. So students understand it in a simple way that when you have to test the hypothesis, then you have to apply the chi-square test under the null hypothesis, and this is specifically done Pearson's chi-square test and variants thereof. So Pearson's chi-square test is used to determine whether there is a statistically significant difference between the expected frequencies and the observed frequencies. So in one or more categories of contingency table. So if we have two frequency tables and if we want to determine that is there any statistical significant difference between the expected frequency or not. So this is how it is done in that way, that frequencies in one or more categories of a contingency table. So let's understand it a more elaborative way. So in the standard applications of this test, the observations are classified into mutually exclusive classes. So if the null hypothesis that there are no differences between the classes in the population is true, the test statistic computed from the observations follows a chi-square frequency distribution. So students, when we are collecting the sample and when we are having the data in frequency, the items are analyzed in the frequencies. So suppose there are 60 questions in a test, and in 60 questions there are, it may be the 5 scale or 3-point scale or 7-point scale. So the respondents will actually give their responses accordingly. And when the researcher is going to analyze this data collection, then he or she will be counting those frequencies. So when counting those frequencies, so it is actually simply understood from a point of view of researcher that there are some frequencies which are more in number and there are some frequency which are less in number. So just to check how the frequencies are significantly different and how much is the variation. So it is actually just to check what is or just to check or to evaluate the difference between observed frequencies, what you have really observed during your test, during your items analysis, and what you supposed, what you assumed during your null hypothesis. We all know that null hypothesis is a kind of tentative solution. So in that tentative solution, you had assumed some sort of solution for that particular problem or research problem you have taken. But somehow you find a difference in observed frequencies. So it should be actually in that way that you are just finding out the difference, how much it is significantly different or not. So just understand, we are not looking at the difference of mean or standard deviation. We are looking at the difference of frequency distribution. Okay, so understand that chi-square is used to evaluate how likely the observed frequencies would be, assuming the null hypothesis, that is true or not. Now, students, let's have a look on the brief history of chi-square test, how it developed and how it is still in continuation with the researchers. So, around 19th century, statistical analytical methods were mainly applied in biological data analysis, and it was customary for researchers to assume that observations followed a normal distribution, such as Sir George Airy and Professor Merriman, whose works were criticized by Carl Pearson in his 1900 paper. By that time, there was a research paper, and Carl Pearson criticized the work of normal distribution observations of George Airy and Professor Merriman. Okay, and at the end of the 19th century, Pearson noticed the existence of the significant skewness with some biological observations also. So, in order to model the observations, regardless of being normal or skewed, the Pearson, in a series of articles published from 1893 to 1916, devised the Pearson distribution, a family of continuous probability distributions which includes the normal distribution and many skewed distributions, and proposed a method of statistical analysis consisting of using the Pearson distribution to model the observation and performing a test of goodness of fit to determine how well the model really fits to the observation. So it was really started with the statistical analysis of consisting of using Pearson distribution, that it observed the frequencies observation and performing the test of goodness, how to fit and how to determine that how well the model really fits to its observation. Now, students, let's understand about Pearson's chi-square test. Pearson is really a renowned name. Carl Pearson is renowned name in the chi-square test. So it is a statistical applied test. It is a test that is applied to sets of categorical data. Like, you have made categories. Suppose, students, you have taken like teachers. So teachers are of different categories. If you are taking university teachers, so teachers may be of assistant professor, associate professor, professor, and if you are taking school teachers, they may be PRT, they may be TGT, they may be PGT. So this is how the category is made. And when you are observing any type of data according to the set categories, and now you are evaluating how likely it is that any observed difference between the sets arose by chance. So in null hypothesis, you must have set a solution, but in actual situation, you must have found something else. So it is the most widely used of many chi-square tests. Its likelihood ratio, Portmanteau's test in time series, etc. So statistical procedures whose results are evaluated by reference to the chi-square distribution. So its properties were first investigated by Carl Pearson in 1900. All right, so just remember it that chi-square's properties were first investigated by Carl Pearson in 1900 in context where it is important to improve a distance between the test statistics and its distribution. So names similar to Pearson chi-square test for statistics are used. It tests a null hypothesis stating that a frequency distribution or creation events observed a sample consistence with a theoretical distribution. The event considered must be mutually exclusive and have total probability 1. So students, a common case for this is where the events each cover an outcome of categorical variable. A simple example is the hypothesis that an ordinary six-sided die is fair. All six outcomes are equally likely to occur. So Pearson's chi-square test is used to assess three types of comparison. So how it is observing the frequencies and how it is making the comparisons. So first is goodness of fit, secondly homogeneity, and thirdly independence. So a test of goodness of fit establishes whether an observed frequency distribution differs from a theoretical distribution. What you have decided in your null hypothesis. So this decides that a test of goodness of fit is establishing by that time. Then a test of homogeneity compares the distribution of counts for two or more groups using the same categorical variable, choice of activity, college, military, employment, travel of graduates of a high school reported a year after graduation, sorted by graduation year, to see if the number of graduates choosing a given activity has changed from class to class or from decade to decade. So a test of homogeneity is actually comparing the distribution of counts for two or more groups, what you have actually set, and then you are doing it in a categorical form. Okay, so first is test of goodness of fit, secondly is homogeneity, and third is a test of independence, which assesses whether observation consisting of measures on two variables expressed in contingency table so are independent of each other, polling responses from people of different nationalities to see if one's nationality is related to the response. So this is how we are going to just make the observation of the frequency, how it is affecting the data, how it is affecting the interpretation, that it is really that something has happened due to one variable. So that's what we are going to see in chi-square test. So taking the introduction in an extended form, so the chi-square test is an important test amongst the several tests of significance which are developed by statisticians. And students, it is developed by Carl Pearson in 1900. Chi-square test is a non-parametric test, not based on any assumption or distribution of any variable. So it is a non-parametric test because it observes the frequencies distribution. Then this statistical test follows a specific distribution known as chi-square distribution. In general, the test we use to measure the differences between what is observed and what is expected according to an assumed hypothesis is called the chi-square test. So basic thing what you have to remember about the chi-square test, that it measures the difference between what is observed during the data collection or data analysis and what is expected according to an assumed hypothesis which you had set before collecting the data. So this is called chi-square test. Now, chi-square test is a hypothesis testing method, students. So two common chi-square tests involve checking if observed frequencies in one or more categories. So how you are going to see it, just check it in that way. So students, just remember when you are looking at chi-square test, so it is a hypothesis testing method. Okay, so hypothesis testing method is something that you have to do when you are doing some research. So research would be useless if you are not checking your hypothesis. So this is how it is working. So chi-square is a chi-square test, the same as chi-square test, yes, x, this x is the Greek symbol chi. This is called chi. What are my choices then? So what are my choices? The correct answer would be, if you have a single measurement variable, you can use chi-square test of goodness of fit test. If you have single variables, there must be single variable and you have to see the frequencies, then you will see this test. If you have two measurement variables, you use chi-square test of frequencies. There are other chi-square tests, but these two are the most common test. All right, students. Now, first of all, let's see the test of goodness of fit of distributions in a very explaining way. So, this test enables us to see how well does the assumed theoretical distribution, such as binomial distribution, Pearson distribution, or normal distribution, fit to the observed data. The chi-square test formula for goodness of fit is x square equals to summation O minus E square upon E. So where O means observed frequency and E means expected frequency. So if chi-square calculated is greater than chi-square tabulated with n minus 1, DF, then a null hypothesis is rejected, otherwise it would be accepted. But there is another situation also, students. If the null hypothesis is accepted, then it can be concluded that the given distribution follows theoretical distribution. So this theoretical distribution is following the null hypothesis acceptance. All right, students. So let's see further how it is working. Important characteristics of a chi-square test. What are the important characteristics? Let's understand them one by one. Number one, this test is as a non-parametric test is based on frequencies, not on the parameters like mean and standard deviation. We have seen in earlier lectures also when we were studying about t-test that we want to see the difference of mean and standard deviation, then in that case we are looking for the parametric test. That was t-test. But chi-square doesn't observe that. It observes based on the observation of frequencies. So the chi-square is actually not that test. So the test is used for testing the hypothesis and is not useful for estimation. So this is how it is working. All right, students. So let's understand it in that way. So this test can be applied to a complex contingency table with several classes, and as such is a very useful test in research work. This test is an important non-parametric test, students, as no rigid assumptions are necessary in regard to the type of population. No need of parameter values and relatively less mathematical details are involved in it. Applications of a chi-square test. So this test can be used in goodness of fit of distributions, test of independence of attributes, test of homogeneity. So these are the applications of the chi-square test: goodness of fit of distribution. Number 2, test of independence of attributes. Then number 3, test of homogeneity. So now let's understand the second type of application of chi-square test, that is test of independence of attributes. So in that, students, test enables us to explain whether or not two attributes are associated. For instance, we may be interested in knowing whether a new medicine is effective in controlling fever or not. So chi-square test is useful. So in such a situation, we proceed with the null hypothesis that the two attributes, new medicine and control of fever, these are the two attributes. We are taking one medicine and we want control of fever. So these are independent, which means new medicine is not effective in controlling fever. So chi-square is calculated is greater than chi-square what tabulated. So at a certain level of significance for given degrees of freedom. So in that case, the null hypothesis is rejected. Like that is null hypothesis is rejected, and that is something two variables are independent. The new medicine is effective. The new medicine is effective in controlling fever, and if a chi-square calculated is less than chi-square tabulated, the null hypothesis is accepted. So that is two variables are independent. So that is new medicine is not effective in controlling the fever. So when null hypothesis is rejected, it can be concluded that there is a significant association between the two attributes. All right, students. So let's proceed further with next type. Now, this is the calculation of chi-square, how it is done. So chi-square is calculated in such manner, that is x square and summation O minus E square upon E. O stands for observed frequency, E stands for expected frequency. If two distributions, observed and theoretical, are exactly alike, so chi-square is 0. But generally, due to sampling errors, chi-square is not equal to 0. Okay, so this has to be taken in care while calculating the chi-square. Now, steps involved in calculating chi-square. So, calculate the expected frequencies and the observed frequencies. Expected frequencies Fe. The cell frequencies that would be expected in a contingency table if the two variables were statistically independent. And observed frequencies is the cell frequencies actually observed in a contingency table. So we just go through observed and expected frequencies. So Fe, that is expected frequency, how it is made, column total, how many columns are there, and row total upon n. So this is how expected frequency is counted. All right, students. So to obtain the expected frequencies for any cell in any cross tabulation in which the two variables are assumed independent, multiply the row and column total. Just multiply and then divide the cell by the product by total number of the cases in the table. Then you will get your expected frequency. This is how chi-square is calculated. So summation Fe minus Fo square upon Fe. Fe stands for expected frequency and Fo stands for observed frequency. So we have to subtract the observed frequency from expected frequency, and then just double it by making it square, and then just divide it with the expected frequencies. So you will get your chi-square very nicely. Now, students, let's understand some conditions set for the applications of chi-square test. So, following are the conditions should be satisfied before chi-square test can be applied. The data must be in the form of frequencies. The frequency data must have a precise numerical value and must be organized into categories or groups. Number 3, observations recorded and used are collected on a random basis. Number 4, all the times in the sample must be independent. So, number 5, no group should contain very few items, say less than 10. In case where the frequencies are less than 10, regrouping is done by combining the frequencies of adjoining groups, so that the combining the frequencies of adjoining group so that the new frequencies become greater than 10. Some statisticians take this number as 5, but 10 is regarded as better by most of the statisticians. So the overall number of item must also be reasonably very large. It should normally be at least 50. All right, so these are some set conditions. Number one, data must be in the form of frequency, that is must, first, and for most condition. It must be in the form of frequency. We don't want any numerical data, we want frequencies, all right? And frequencies can be converted in the form of numbers, numerical form. So then secondly, precise numerical value must be given to categorize or group what we have chosen earlier. Then observation is done on the random basis. Items are in sample are independent. Then no group should contain very few items, say less than 10. Okay, so these are some important conditions, students, which must be taken in consideration while we are applying chi-square test. Now, students, let's understand about types of chi-square test. So, you use a chi-square test for hypothesis test about whether your data is as expected or not. So, the basic idea behind the test is to compare the observed values in your data to the expected values, that you would see if the null hypothesis is true or not. So there are two commonly used chi-square tests, the chi-square goodness of fit test, which I have just seen, chi-square test of independence and homogeneity, but two main are which I have told you just now. So both tests involve variables that divide your data into categories. As a result, people can be confused about which test to use. The table below compares the two tests. Visit the individual also. So this is like chi-square test to see examples also with details on assumptions and calculations. See how it is fit into the table. So first of all, in second column, chi-square goodness of fit test variables are given and chi-square test of independence results are given. Now, say first is the basis, first column is basis, how it is done, choosing a chi-square test, how you would choose. When you have set frequencies in front of you, and how would you choose between chi-square goodness of fit test or chi-square test of independence? How would you recognize that? So now just see that. Number of variables. If you have one variable, then you go for chi-square goodness of fit test. If you have two variables, then you go for chi-square test of independence. Clear, students? Now, second thing, we go to see the purpose of test. So decide if one variable is likely to come from a given distribution or not. So we are going to do chi-square goodness of fit test. But if we decide if two variables might be related or not, then we are going to definitely see chi-square test of independence. Then secondly, example you just see, decide if bags of candies bags are there and have the same number of pieces of each flavor or not. So there are some candies of bags and same number of pieces of each flavor or not. And in another test of independence, decide if movie goers' decision to buy snacks is related to the type of movie they plan to watch. So this is how it is related or not. So two variables are there. And movie, the person is going to see a movie, and if the type of movie is deciding this particular snack he is going to buy. If the horror movie is here, maybe he's going to have a coffee or something else. But if a comedy movie is here, maybe the person is going to have popcorn. So this is how deciding two variables might be related or not. Then third basis is hypothesis in example. Hypothesis, proportion of flavors. Different flavors of candies are the same. Maybe there are same flavor. How much it is, maybe strawberry flavor in each candy is same or different. So you are just going to check goodness of fit test or not. So by that time your proportions of flavors are not the same. Is it same? You must just imagine, students, you are having 10 candies with you and all are called strawberry flavor candies. But 10 candies are not having the same proportion of flavor which you are expecting. So there is a difference in expected frequency and observed frequency. But when we are talking hypothesis of chi-square test of independence, the proportion of people who buy snacks is independent of movie type. That means there is no difference. The second hypothesis, which may be there, proportion of people who buy snacks is different for different types of movies. So this is how chi-square goodness of fit test is used and chi-square test of independence is used. So understand it in a very elaborative manner, students, and I hope you will be understanding it very quickly. Then theoretical distribution used in the test. Both are chi-square. Then we have to see the degrees of freedom also. Number of categories -1. In our examples, numbers of candies must be -1. So how it is? Number of candies are -1. And then in our example, which is fit to chi-square test of independence, that is in our example, number of movie categories -1 multiplied by 1, because snack purchase is a yes or no variable, and then 2 minus 1 equivalent to 1. Okay, students? Now, students, we are going to see how to perform a chi-square test. It is very important to know that how we are going to perform it. That's very necessary. So for both the chi-square goodness of fit test and chi-square test of independence, you perform the same analysis steps listed below and visit the pages for each type of test to see these steps in action. Now you define your null and alternative hypothesis before collecting your data. So first of all, you do it. Okay. Then decide on the alpha value. This alpha value involves deciding the risk you are willing to take of drawing the wrong conclusion. For example, suppose you set alpha value 0.05 when testing for independence between a relation between two variables. And here you have decided on a 5% risk of concluding the two variables are independent when in reality they are not. So check the data for errors. Check the assumptions for the test. So we'll then perform the test and draw your conclusions. So it is very necessary to define your null hypothesis and alternative hypothesis very clearly in words before collecting your data, and decide the alpha value also. The alpha value actually involving you, it is leading you to decide the risk you are willing to take when you are drawing the conclusion for wrong conclusion. Okay, students, this is how to perform the chi-square test. Necessary conditions we have discussed again. Then both chi-square tests in the table above involve calculating a test statistics. So the basic idea behind the test is that you compare the actual data values with what would be expected if the null hypothesis is true. So the test statistic involves finding the squared difference between actual and expected data values and dividing the difference by the expected data values according to the given formula. You do this for each data point and add up the values. Okay, students, so just remember the step by step. The basic idea behind the test is that you compare the actual data values with what would be expected if the null hypothesis is true. So the test statistics involve finding the square difference between actual and expected data values. So dividing that difference by the expected data values. So you do this for each data point and add up the value. Then you compare the test statistics to a theoretical value from the chi-square distribution. So the theoretical value depends on both the alpha value, which you have decided how much probability of the risk, and the degrees of freedom for your data. Okay, students. Now let's have a look on the limitations of chi-square test. What is said? So the data is from a random sample. Random sample, it is very necessary, or it is a very major limitation that data must be from a random sample. This test applied in a four-fold table and will not give a reliable result with 1 degree of freedom if the expected value in any cell is less than 5. Yes, I repeat, this test is applied in a four-fold table, will not give a reliable result with 1 degree of freedom if the expected value in any cell is less than 5. In such case, 8th correction is necessary. This is another modified form of chi-square test. Reduction of the mode of is O minus E by half. So even if 8th correction, the test may be misleading if any expected frequency is much below 5. In that case, another appropriate test should be applied. In contingency tables, larger than 2 multiplied by 2, 8th correction cannot be applied. So interpret this test with calculation if sample total or total values in all the cells is less than 50. Students, this test tells the presence or absence of an association between the events but doesn't measure the strength of the association, how strongly it is related. It doesn't tell you. This will tell you definitely that okay, these two variables are related, associated, present, association is present or absent. But this is not going to tell you how strong it is. So this test doesn't indicate the cause and effect. If only tells the probability of occurrence of association by chance. So the test is to be applied only when the individual observations of sample are independent, which means that the occurrence of one individual observation has no effect upon the occurrence of any other observation in the sample under consideration. Now students, have a look on chi-square test for variance in normal population, how it is done. So if a sample of size n is taken from population having a normal distribution, then there is a result distribution of sample variance, which allows a test to be made of whether the variance of the population has a predetermined value. For example, a manufacturing process might have been in stable condition for a long period, allowing a value for the variance to be determined essentially without error. So suppose that a variant of the process is being tested, giving rise to a small sample of n product items whose variation is to be tested. So the test statistics tree in this instance could be said to be the sum of squares about the sample mean divided by nominal value of the variance. So the value to be tested as holding, then T has a chi-square distribution with n minus 1 degrees of freedom. So for example, if the sample size is 21, the acceptance reason were for T with a significance level of 5% between 9.59 and 34.17. Suppose there is a city of 10 lakhs residents with 4 neighborhoods A, B, C and D. Or you can just change the number 10 lakh or 1 crore or anything. A random sample of 650 residents of the city is taken, as their occupation is recorded as white collar, blue collar or no collar. So this is how categorical data is arranged. So the null hypothesis is that each person's neighborhood of residence is independent of the person's occupational classification. Now the data are tabulated as you can see on my screen. This is given to you A, B, C, D and white collar, blue collar, no collar and total. So you can see how the data is distributed in frequencies. Now, these are some references, students, for your more study purpose. You can go through them and study well about it. Now, students, let's have a look on MCQs for your purpose of more studying. Now, let's enjoy doing the questions at the end of the class. What is the mean of a chi-square distribution with 6 degrees of freedom? So, it's 4, 12, 6 or 8. Correct answer is C, and the correct explanation is given here on your screen. So by the property of chi-square distribution, the mean corresponds to the number of degrees of freedom. So degrees of freedom 6, hence mean will be 6. So the correct answer is 6. Now, next question. Which chi-square distribution looks the most like a normal distribution? A, chi-square distribution with 4 degrees of freedom. B, chi-square distribution with 5 degrees of freedom. C, a chi-square distribution with 6 degrees of freedom. D, a chi-square distribution with 16 degrees of freedom. So the correct option is D, and the correct explanation is that when the number of degrees of freedom in chi-square distribution increases, it tends to correspond to normal distribution. When it is increasing, it is becoming normal distribution. So the option with the maximum number of degrees of freedom is 16. So when it is increasing, it will be most likely normal distribution. All right. So the maximum number is 16. That's why it looks the most like a normal distribution in chi-square distribution. Now next question, students. Suppose a person has 8 red, 5 green, 12 orange and 15 blue balls. So that means we are having 4 categories: red, green, orange and blue. And test the null hypothesis that the color of the balls occur with equal frequencies. What is the chi-square value you get? 5.6, 5.68, 5.86, 5.8. Yes, the correct answer is option D, 5.8. And the correct explanation of it, let's see it. By chi-square test, we get observed frequency. So FO is 8 plus 5 plus 12 plus 15 divided by 4, that is standing for 4 categories. So answer is 10. Then chi-square is summation FE minus FO upon F to FE. So the sum of each expected minus observed square upon expected. So that is 10 minus 8 upon 10 plus 10 minus 5 square upon 10, 10 minus 12 square minus upon 10 plus 10 minus 15 square upon 10. So the total value which we have got out of this formula, that is 5.8. You have to calculate that. I have just made it easy for your answer purpose, and you can review the video and you can just tell your correct answer also. Now students, let's have a look on another type of example, and by this you will be definitely learning about the chi-square test. A bag contains 80 chocolates. This bag has 4 different colors of chocolate in it. If all 4 colors of chocolates are equally likely to be put in the bag, what would be the expected number of chocolates of each color? So understand students, there is a bag full of 80 chocolates, and this bag has 4 different colors of chocolate in it. If all 4 colors of chocolate were equally likely to be put in the bag, maybe 20, 20, 20. So what would be the expected number of chocolates of each color? So we are just expecting. Maybe I am expecting 20. So maybe it is expected, but what is observed? So how the difference I'm going to see, that is from chi-square test. So answer C is most appropriate, that is 20. That is also given here. So, and the correct explanation, if all 4 colors were likely to be put in the bag, then the expected frequency for a given color number would be 1/4 of the chocolates. So 80 divided by 4, we get 20. So this is how I have got my expected number. Now students, let's have a look on this question very carefully. We'll be understanding very clearly about chi-square test. A faculty is interested in whether there is a relationship between gender and subject at his college. He tabulated some men and women, some men and women on campus and asked them if their subject was mathematics, geography, and science. You can see it from table that a faculty has studied this. Mathematical and geography and science subjects, women and men. What would be the expected frequency of women in geography based on this table? So this is how the data is actually kept in the form of table. Women, when it was mathematics was observed, then 10, then geography 14, then science is 10, men 11, 22, 14, 23. So 21, 36, 24 total we are having. So how would be the answer? So the correct answer would be 4 options are given. So the correct would be 13.12. An explanation, the expected value of women in social sciences is the product of the total number of the women and the total number of social science majors divided by the total number of participants. So it is 13.12. So this is how students we have discussed about chi-square test, and I really hope you have enjoyed studying chi-square test and you know about what is chi-square test, that it is simply a hypothesis testing method. And 2 common chi-square tests involve checking if observed frequencies in one or more categories match expected frequencies or not. So this is how you have studied about chi-square test, and in chi-square test we have seen test of goodness of fit of distributions, and then we have seen test of fitness, homogeneity, and then we have seen test of independence of attributes. So this is how it is working. We have also seen the formulas, how it is calculated, and we have seen the conditions for the applications of chi-square test, how it is done, and then we have seen the types of chi-square test in an elaborative manner, and we have also seen a very good table about chi-square test which is actually fitting to chi-square goodness of fit test. and chi-square test of independence. We have seen the difference how it is used. So, for example, if you have one variable, you are going to use chi-square goodness of fit test. If you are having two variables and you want to see that if there is association present or not, you are going to see the chi-square test. So, this is how the number of variables, purpose of the test, and hypothesis, examples all are set according to the different types of chi-square test. So, then we have seen about how to perform a chi-square test. So we have to define our hypothesis. We have to decide on alpha value also. So alpha value is something which is deciding your risk you are willing to take off drawing the wrong conclusions. So I have given you example. Suppose you have chosen alpha value 0.05 when testing for your independence. So here you have decided on a 5% risk of conducting or concluding the two variables are independent when in reality they are not. So this is how you are checking the data for errors. Then in the continuation, you are going to distribute the frequencies, how you are watching it. So the basic idea behind the test is that you compare the actual data values with what would be expected. So you have already expected through your null hypothesis that I'm expecting this type of data. But what you have observed during data was entirely different, or maybe in some cases it is correct. So that if it is correct, then your hypothesis is true, or if it is not correct, then your hypothesis is not true. So this is how it is working. So I hope you have understood about limitations also. Thus, that this test is data is collected from random sample and we applied in fourfold table also. So this gives us a reliable result. So students, I hope you have understood about chi-square test today, and I really hope that you will apply the chi-square test if it is suitable in your research with appropriate manner. So, see you students in the next class. Till then, take care and stay safe and stay healthy. See you in the next class.